Hello and welcome back. The next topic we'll be discussing is E and Z designations for alkenes. So remember, if we had cis-2-butene versus trans-2-butene, these molecules can be named with the cis and trans prefixes. But that doesn't work for all molecules that have double bonds. For example, what we have here, we have this molecule that has a double bond in it, but it doesn't have two of the same groups attached. You have to have two of the same groups on the alternating carbons of the double bond in order to be cis or trans. So cis or trans isn't adequate to differentiate between these two diastereomers, and so we need to use a different kind of notation, and that's what the E and Z notation is for. Okay? So in order to label a molecule E or in Z, the E or Z, we have to prioritize the groups attached to the carbon bond based on atomic number. So this is very similar to what we did to do the R and S configuration, but E and Z is a little bit simpler. So split that double bond right down the middle and compare the left side versus the right side, okay? So the left side of the double bond is going to have two groups. The right side is going to have two groups. So we need to figure out which group on the left is higher priority and which group on the right is higher priority. So we use atomic number just like we did with R and S. So for the group on the left, we have fluorine versus carbon. Fluorine is higher priority because it's atomic number 9 versus carbon being number 6. And so that gives fluorine number 1 and carbon number 2 on the left, okay? On the right, we've got nitrogen versus hydrogen. Nitrogen is atomic number 7 versus hydrogen being 1. So nitrogen is priority number 1. Hydrogen is number 2. So what we see is that the same group, or let's just go back to this, the higher priority groups are on the same side. The higher priority group is on the same side of the double bond here. If the higher priority group is the same side, it gets the designation of Z. Z stands for zusammen in German, which means together, okay? And here we have the diastereomer, which has the fluorine and the nitrogen on opposite sides. So if we consider that, looking at the left, we've got fluorine versus carbon. Fluorine's number 1. On the right, we've got hydrogen versus nitrogen. Nitrogen's number 1 and hydrogen's number 2. Okay, so the higher priority groups on this molecule are on opposite sides, and we use the designation for that one as E. E stands for entgegen in German, which means opposite. So we use Z and E as designations to determine where the higher priority groups are in relation to each other on the double bond. Okay, so let's see if we can assign the configuration as E or Z in these alkenes. So for A, let's go ahead and redraw this molecule over here. We could see it. Okay, so where's our double bond? It's right here. Okay, what do we have attached on the left? We've got carbon versus carbon. So these are a little trickier than our examples, right? Okay, so again, we're going to move away until we find the first point of difference. On the left, the carbons in orange, we're going to compare them. Let's call the top one A and the bottom one B. Carbon A has a carbon, a hydrogen, a carbon, and a hydrogen attached. Carbon, carbon, hydrogen. Carbon B has a carbon, a hydrogen, and a hydrogen attached. Okay, so carbon A is going to be higher priority. Let's give that one priority 1 and B priority 2. Okay, so on the right side of this molecule, we've got a hydrogen versus a carbon. Carbon is higher priority than hydrogen, so this is 1 versus 2. Okay, so the higher priority groups are on opposite sides, so we use the designation E for opposite there. Okay, so the next molecule, let's see if we've got some room. Yeah, we got some room down here. So the next molecule I'm going to draw just below. This is, it's not very neat, but think you'll get the idea there. Okay, so let's split our double bond right down the middle and look at the carbons that are on each side. The carbon on the left has the two groups carbon versus carbon. So we have a tie. We have to get a tiebreaker here. Okay, so let's call these carbons A and B. Okay, so A has hydrogen, hydrogen, hydrogen attached. B has carbon, carbon, hydrogen attached. So B is going to be number 1, A is going to be number 2. Okay, so let's look at the right side of that double bond. We've got carbon versus carbon. Okay, let's call these A and B. A has carbon, carbon, hydrogen attached. B has carbon, carbon, carbon. So B is higher priority than A. So the higher priority groups are on the same side. So the designation is Z. So you can remember Z for the same side. Okay, so that'll help you remember the designation. The next molecule I'm going to redraw down here. In fact, I'll just go ahead and redraw both of those while I'm at it. That one versus this one. Okay, so on the molecule on the left, we split that double bond in half and we have left versus right. On the left, we have carbon versus fluorine. So carbon's going to be number 1, atomic number 9 versus fluorine's going to be number 1. That's atomic number 9 versus carbon being number 6. Okay, and then we have on the right carbon versus carbon. Carbon at the top, oh goodness, carbon at the top has 2 hydrogens, so it has oxygen, hydrogen, hydrogen. The carbon at the bottom has carbon, carbon, carbon. Okay, so oxygen trumps carbon, so the carbon at the top is number 1, and the carbon at the bottom is number 2. So we've got the higher priority groups on the same side. So this one is Z for the same side. Okay, this molecule on the right here, I've got right versus left. Left has chlorine versus carbon, so that's number 1 versus number 2, chlorine being higher. On the right, we've got carbon versus hydrogen, so carbon is higher than hydrogen. So we've got the higher priority groups on the same side, so it's Z. All right, so that's E and Z designations. Thank you for watching.